Did you know that a barren volcanic wasteland can, over time, burst forth into a lush, vibrant forest? Picture this. An endless expanse of ashen rock suddenly transforms into a bustling metropolis of trees, flowering plants and wildlife. A living, breathing miracle of nature. Today on Eco Era, we're diving headfirst into the wild and wonderfully unpredictable world of ecological succession. This isn't your average biology lecture, it's nature's ultimate makeover show where every disturbance sparks an epic story of renewal, resilience, and yes, plenty of laughs along the way. Imagine nature as an unpredictable artist, splashing wild colors on a blank canvas every time a storm, eruption, or human intervention resets the stage. In the next 20 minutes, you'll learn what ecological succession is, what causes ecological succession, both natural and human-induced, the various types and mechanisms that drive ecological succession, and the detailed process that turns barren landscapes into thriving ecosystems. Buckle up, because this journey is packed with high-density facts delivered in bite-sized 10-second segments, and yes, there are eco-jokes to keep your smile wide. Let's jump right in. At its heart, ecological succession is the gradual, predictable process by which a community of organisms transforms a barren or disturbed landscape into a complex, stable ecosystem. Think of it as nature's version of a long-term renovation project where a patch of lifeless rock evolves into a thriving forest. Originally described by Frederick Clements in 1916 as a march toward a climax community, the idea was later challenged by Henry Gleason, who showed that succession is more like a choose-your-own adventure filled with unexpected twists and species-specific quirks. In essence, ecological succession is nature's epic saga of change where even the tiniest moss can kickstart an entire forest. It's a story of resilience and recovery that unfolds over months, years, decades, or even centuries. So what sets this transformation in motion? Ecological succession is triggered by disturbances or the creation of new habitats, and these causes fall into two broad categories: natural disturbances, fires, floods, landslides, storms, volcanic eruptions, glacial retreats, and even earthquakes can completely reset an ecosystem. For instance, the Yellowstone fires of 1988 cleared away old growth, allowing lodgepole pines and a host of new species to emerge in a spectacular recovery. Anthropogenic disturbances? Human activities like logging, agriculture, urban development, mining, and pollution also play a major role. Abandoned farmland in New England often undergoes secondary succession, where the existing soil and seed bank enable a rapid regeneration of diverse forests. Here's a fun one to lighten the mood. Why are forest fires so popular at ecological parties? Because they're known for sparking new relationships. Ecological succession comes in two primary forms. Primary succession. This occurs in lifeless areas, volcanic lava flows, retreating glaciers, or bare rock surfaces. Pioneer species like lichens, mosses, and bacteria are the first to colonize these harsh environments, gradually building organic matter and forming soil. A prime example is Surtsey Island in Iceland, born from a volcanic eruption in 1963. From nothing, a complex ecosystem eventually emerged, a true nature miracle. Secondary succession. In contrast, secondary succession happens in areas where a previously established ecosystem has been disturbed, but where the soil and seed bank remain intact. This process is much faster. Think of the rapid regrowth of forests in Yellowstone National Park after the 1988 fires. Grasses, wildflowers, shrubs, and eventually tall trees reclaimed the land with remarkable speed. And here's a light chuckle. How did the oak tree feel about replacing the grasses? A little shady, but it knew its moment in the sun was coming. But what drives these transitions? Three key mechanisms steer ecological succession. 1. Facilitation. Early colonizers improve the environment for later species, for example, lichens breaking down rock to build soil. 2. Inhibition. Sometimes pioneer species block later arrivals by monopolizing resources. Think of dense grasses that prevent tree seedlings from sprouting. 3. Tolerance. Later species eventually outcompete the pioneers simply because they can better handle the modified conditions, like shade-tolerant trees replacing sun-loving grasses. Here's another pun for you. What do climax species use to communicate? Mature conversations in deep shade? Let's break down the process of ecological succession step by step. It's nature's very own recipe for renewal. Step 1, nudation, or the initial disturbance. The process starts with nudation, where a disturbance, whether a volcanic eruption, landslide, or human clearing, creates a blank canvas. Think of it as nature wiping the slate clean, leaving behind a lifeless surface ready for new life. Step 2, migration or colonization. Next comes migration. Pioneer species like lichens and mosses move into the newly available space. They travel by wind, water, or even by hitching a ride on animals. Nature's slow and steady road trip with every seed on a mission. Step 3, Ecesis or establishment. Once the pioneers have arrived, they work hard to establish themselves. They germinate, take root, and start modifying the environment by breaking down rock and accumulating organic matter. This creates a more hospitable setting for future plant generations. Step 4, aggregation or population increase. As conditions improve, the population of pioneer species rapidly increases. More individuals mean more organic material is added to the soil, enhancing its fertility and setting the stage for more complex life forms. Step 5, competition and reaction. Now the competition begins. Different species vie for limited resources like sunlight, water, and nutrients. Some species inhibit others by monopolizing resources, while others simply tolerate the conditions better and gradually edge out the pioneers. Quick joke break. Why do pioneer species dislike late successional species at parties? Because they always show up late and then shade everyone else. Step 6, stabilization, also known as the climax community. Finally, the ecosystem reaches stabilization, forming a climax community. A mature, balanced state where long-lived species dominate and the ecosystem becomes relatively stable. Although climax might sound dramatic, it's simply nature settling into a sustainable rhythm until the next disturbance prompts another cycle of renewal. Understanding ecological succession isn't just a fascinating natural phenomenon, it has real-world implications. Here's why it matters. Biodiversity conservation. Each stage of succession creates unique habitats that support diverse species, ensuring ecosystems remain resilient and vibrant. Soil development and nutrient cycling. As pioneer species build up organic matter, they enhance soil quality, which in turn supports more complex plant communities, vital for agriculture and forest health. Restoration ecology. By mimicking natural succession processes, we can rehabilitate degraded lands, turning barren fields and polluted sites into thriving habitats that benefit both wildlife and human communities. Climate adaptation. Understanding how ecosystems recover and evolve helps us predict how they will adapt to climate change, guiding effective conservation and sustainable management strategies. Let's quickly recap our epic journey through ecological succession. We defined ecological succession as nature's long-term renovation, from barren rock to a thriving ecosystem. We examined the causes, from natural disturbances like wildfires and floods to human-induced factors such as logging and urbanization. We explored the two main types, primary succession, which starts from absolute scratch, and secondary succession, which rebuilds on pre-existing foundations. We uncovered the key mechanisms, facilitation, inhibition, and tolerance that guide these transformations. And finally, we walked through the process from the initial disturbance to colonization, establishment, population growth, competition, and stabilization into a climax community. Every phase of this journey is a testament to nature's extraordinary ability to recover and reinvent itself. Even the tiniest patch of moss can be the spark that ignites a forest. Now, here's the big reveal. Ecological succession is not merely about change, it's the ultimate narrative of interconnectedness. Every disturbance is nature's way of hitting the reset button, inviting new growth and renewal. It's a powerful reminder that every ending is simply the start of something new. Before we wrap up, here are a few more eco-jokes to keep your spirits high. What do you call grasslands transitioning to forests? Turf wars. Why are mosses and lichens such great pioneers? Because they never take their environment for granted. And why did the tree feel guilty after shading out pioneer plants? It realized it had become part of the canopy conspiracy. Let's now bring these concepts to life with some real-world examples that showcase nature's resilience in action. Consider the eruption of Mount St. Helens in 1980, a catastrophic event that erased an entire forest and left behind a barren landscape of volcanic ash. Yet from this desolation, nature began its remarkable recovery. Pioneer species like fireweed and alder trees emerged, breaking down ash and building soil, paving the way for a diverse, thriving forest to re-emerge. Research following this event has given ecologists invaluable insights into primary succession. Now look at abandoned farmland in New England. Over time, these fields, once cleared for agriculture, have transformed through secondary succession. First come the grasses and weeds, then the shrubs, and finally mature forests take root. Studies at the Hubbard Brook Experimental Forest in New Hampshire have documented these changes in stunning detail, proving that even landscapes scarred by human activity can reinvent themselves. And now, let's take a breather with some more eco-humor to keep those smiles wide. Imagine if the moss and algae broke up after colonizing bare rock. Apparently, their relationship was built on rocky foundations. Or picture the pioneer lichen whispering to the moss, "Stick with me, I'll get you into fertile ground." Here's another. Why are forest fires so popular at ecological parties? Because they're known for sparking new relationships. Even the mighty oak tree gets in on the fun. When it replaced the grasses, it felt a little shady, but deep down it knew its moment in the sun was coming. And one more twist on timing. Why do pioneer species dislike late successional species at parties? They always show up late and then shade everyone else. So why is understanding ecological succession so crucial? This process isn't just fascinating, it's a cornerstone for managing our natural world, biodiversity. Each stage of succession creates distinct habitats, ensuring a rich tapestry of life that makes ecosystems resilient. Soil and nutrient cycling. As pioneer species build organic matter, they improve soil quality, which supports more complex and sustainable plant communities. Restoration, ecology, mimicking natural succession allows us to rehabilitate degraded landscapes, turning barren fields into thriving ecosystems that support both wildlife and human communities. Climate resilience. Insights into succession help us predict and manage how ecosystems adapt to climate change, ensuring a sustainable future for all. Let's pause and recap our epic journey. We defined ecological succession as nature's long-term renovation, from barren landscapes to vibrant ecosystems. We examined its causes, ranging from natural events like wildfires and floods to human-induced activities like logging and urban development. We distinguished between primary succession, which starts from absolute zero, and secondary succession, which builds on existing foundations. We explored the mechanisms driving these changes: facilitation, inhibition, and tolerance. And we detailed the step-by-step process, from nudation through migration, establishment, aggregation, competition, and finally stabilization into a climax community. Every step in this journey is a testament to nature's incredible power to rebuild and reinvent itself, even after the most devastating events. Now here's the big reveal. Ecological succession is not merely about change. It's a vivid narrative of interconnectedness and resilience. Every disturbance, whether a volcanic eruption or a human clearing, is nature's way of hitting the reset button, offering a fresh start. It reminds us that every ending holds the promise of a new beginning. If you enjoyed this deep, humorous, and fact-packed exploration of ecological succession, join the Eco-Era community. Hit that like button, subscribe for more engaging eco content, and share your favorite example of nature bouncing back in the comments below. Let's build a space where we celebrate our planet's resilience and share a few laughs along the way. In conclusion, ecological succession is nature's epic saga, a dynamic, ongoing process of destruction, recovery, and growth. From the initial shock of a volcanic eruption or a human disturbance to the gradual establishment of pioneer species, the accumulation of organic matter and the fierce competition that eventually gives rise to a stable climax community, every phase is a celebration of life's persistence and adaptability. This journey through ecological succession teaches us that change, no matter how daunting, is not an end, but a new beginning. It shows us that nature has a remarkable way of healing itself, turning challenges into opportunities, and that resilience is woven into the very fabric of life. Thank you for joining us on this wild, humorous, and enlightening exploration of ecological succession here on Eco-Era. The next time you see a recovering forest or a tiny patch of green emerging in an unexpected place, remember, you're witnessing nature's incredible process of renewal in action. Keep exploring, keep laughing, and stay curious about the world around you. Let's keep it green and keep it growing. Remember, every time you see nature bounce back, you're watching ecological succession in action, nature's very own watch me grow moment.